Here in example 7, we want to find the domain of this function of h of x. Okay. First thing I notice is it's a rational function. So right away, rational, I think of that everything, this denominator cannot equal 0. Because as soon as I start dividing by 0, you get undefined or your calculator says error. So what I'm about to show you are the exact steps on how you're going to find the domain when you have a variable in the denominator. So yes, when you want to say, do I do this every single time? Yes, do this every single time. Just take your denominator, so whatever's sitting down there, in this case it happens to be 2x plus 1, and go, okay, 2x plus 1 cannot equal 0. Do that every single time. Whatever's sitting down there, to say cannot equal 0. And then just get x by itself. So let's move 1 across. So 2x cannot equal negative 1. Divide by 2. It says x cannot equal negative 1/2. Alright, now outside of just putting this in interval notation, we're technically done. We don't care about the variable in the top. Don't have to worry about that. Because you can always have a 0 in the top. But you can never have a 0 in the bottom. And let me show you why. Let's just take 2 seconds. Because if I plugged in negative 1/2 in the denominator, 2 times negative 1/2 plus 1, well, a half of 2 is 1, and it's negative, so negative 1 plus 1 will give you 0. So this is the only value of x that will cause 0 to go down there. All right. And if we put this, let's think about a number line. I just can't equal that number. I can equal anything to the left of that number. I can equal anything to that right of the number. I just can't equal that number. So if we want to tell us our domain and we want to list it in interval notation, let's describe what was shaded here. Everything to the left. So how far left is that shading going? Well, it's going off to forever in the negatives. It's going, now as I go right across it, as I'm going this direction, it gets up to negative 1/2. I can't equal it. And then I'm going to skip over it, start right on the other side of it, and then go off to positive infinity. And remember how we're going to link that is a union. So anytime you want to say basically everything except for one number, this is how you're going to do it. You're going to say everything to the left of it and everything to the right of it, but not including it because we're not going to put brackets in there. Box that up, and there's your answer for the domain for that function. So every time you have a variable in the denominator, just do that. Take your denominator, set it not equal to 0, and then just write it like that. As simple as this. Okay, if we go to example 8, this one's your case number 2. What do you do whenever you have a radical? Okay, again, just like what we did, there's the same steps. You're going to use these steps every single time. And here's the steps for the radical. Take whatever's sitting down there. In this case, is 6 minus x. And we say, okay, whatever's in that radical has to be positive. Well, positive in math world means greater than or equal to 0, right? So whatever's down there, whatever's underneath this radical, just make it greater than or equal to 0. And finish solving out. So move the 6 over. Negative x is greater than or equal to negative 6. And I'm going to divide. Let me write it like this. I'm going to divide by negative 1. And remembering back to chapter 1, anytime I divide by a negative number, I've got to reverse that inequality symbol. So x is now less than or equal to 6. Okay, so for our domain, let's get out the number line and just kind of see what this is referring to. If this is 6, what this is saying is anything equal to 6 but smaller than that. So everything to the left of it. So if I want to put that in interval notation, the farthest left that shading is going to go is off to negative infinity, and the farthest right it ever gets up to is 6 and includes it. And let's just double check. Pick anything in this range. How about 0? Can you take the square root of 6 minus 0? Yep. How about negative 10? What's the square root of 6 minus negative 10? Well, that's the square root of 6 plus 10, which is 16. Win 4, that works out. But start picking something over here. How about 7? What's 6 minus 7? That's negative 1. And see, that doesn't work, does it? Okay. So anytime you're given a rational function, just take your denominator and make it not equal to 0. Anytime you're given a radical, take whatever's sitting underneath there and make it greater than or equal to 0. As simple as that. Okay, so for then example 9, we want to find the domain of this function, and look, we have variables in the denominator. So right away I think, all Alright, 3x squared minus 2x minus 1 cannot equal 0. So how do I finish solving this one out? Well, this one's quadratic. The one up there in example 7 was linear, so we just got x by itself. How do I do a quadratic? We start factoring, or we use the quadratic formula. So let me factor this. 3x and x. The factors of 1 are going to be 1 and 1. One's positive and one's negative. We want the largest one, so the outside to be negative, so we can add up to the negative 2. Okay, so 3x plus 1 cannot equal 0. X minus 1 cannot equal 0. Working this out a little bit, move the 1. So 3x cannot equal negative 1, or x cannot equal negative 1/3. Move this 1 over, and it's saying x cannot equal positive 1. Okay, so we want to work with these two and write our interval notation. So basically we're going to include every single number possible except for these two. Up above we included everything possible except for negative 1/2. So we went all the way up to negative 1/2 and everything past negative 1/2. We're almost doing the exact same thing here. If I draw that number line, so here's negative 1/3 and here's 1. So I'm going to do everything up to that, skip it, everything past that, stop at 1, but skip that and go past that. So I almost have 3 separate segments here. So let's describe those 3 segments in interval notation. So the domain, I'll put D for domain, start far, far left, so always have to go smallest to largest. So that shading starting at negative infinity, it's going right up to negative 1/3, skipping it, over it, picking right back up after negative 1/3, going this time instead of just positive infinity, only going up to 1. We're going to skip it, start back up at 1, and go right past it, all the way off to positive infinity. And that right there is the full domain for this whole graph. So it just has 3 segments, so we have to write 3 segments for our domain. If I go back up to example 7 real quick, because there were 2 segments to the left of negative 1/2 and to the right, I had 2 segments here in my domain. So if you got 4 segments, then you're going to have 4 segments. Okay, well, let's try example 10. We want to find this time the domain in the range for this function by graphing it. Okay, so what we're graphing is y equals, remember function notation stands for y, so y equals 9 minus x squared. And one of the easiest ways to graph a function is just to go right to your xy charts. So let's just pick some values. How about negative 2, negative 1, 0, 1, and 2. So if I plug in negative 2, it would be 9 minus negative 2 squared. So 9 minus 4, which is 5. 9 minus a negative 1 squared. So 9 minus 1 is 8. 9 minus 0 squared is 9. 9 minus 1 squared is an 8. And then 9 minus 2 squared, running out of room here, but it's 5. Okay, let's see if we can get this graph. We've got large values going up there. I'm going to go 3, 6, 9, 12. I'll go 3 right there, but I'll go by 1s on the x-axis. Okay, at 0, we're up at 9. Okay, at negative 1, we're up at negative 8. So right about there. At negative 2, we're up at 5. At 1, we're up at 8. And 2, we're up at 5. Okay, so the graph's kind of coming down like this and going like that. Okay, so if I want to list off the domain, what I need to think here for the domain is how far left is that graph going and how far right is that graph going. Well, as the graph is coming down, isn't it also spreading to the left? And as it's coming down, it's spreading to the right. And it's going to keep spreading to the left and right forever and ever and ever. So spreading to the left forever is negative infinity. Spreading to the right forever is positive infinity. And let's go back to our equation. This equation right here. Are there any variables in the denominator? Nope. Are there any variables underneath the square root sign? Nope. So remember what that third thing said? That if you don't have a square root and you don't have a variable in the bottom of a fraction, then your domain is always going to be all real numbers. And that kind of shows you here. Let's do something new. How about the range? We've never really looked at the range yet so far. The range is always your y values. So what I want to know is smallest to largest. How far down does that graph go and how far up does it go? Well, as we're splitting left and we're splitting right, aren't we going down, down, down forever and ever and ever? We're going down towards negative infinity. Now as I come back up, as I'm going towards the top, the highest y value we ever get to is 9, and we can actually equal 9, so I'm going to put a bracket. And there's the answer for the range. Let's go on to example 11.